We'll begin session 3, except we can't quite do it here. There we go. Now we'll start session 3. This is the home page of the Critical Infrastructure Protection desk for the Department of Homeland Security energy sector. In the upper left corner we see a map showing the 10 NERC regions. The region in red indicates an alert, as also shown in the regional grid health chart on the upper right. Each region is evaluated for its security based on its total regional control error. This is the sum of all the area control errors in each region. We also indicate the tendency up or down. They are rated based on the severity of the situation, and we see in the MAC area has the highest area, and it's indicated by a red alert. We also show other information in frames on the page. We show the current weather in Washington, D.C., a calendar, an inbox, a threat assessment from DHS can be shown on the home page. The operator would click on the area indicated in red, and this will drill down into the MAC area, showing first a map image of the critical control areas in that region, and these are Baltimore, Philadelphia, and Washington. Around each area is a circle of color determined by the frequency value departing from the nominal 60 Hertz. So green is between 59.98 and 60.02. These are the NERC regions. Yellow is below that area, blue is very low, and red is very high. This screen is updated dynamically based on measurements from 3 areas, Washington, Baltimore, and Philadelphia, where we have in place arbiter phaser measurement units that are sending frequency and phase angle data to the resting MTC at the rate of 20 measurements per second. These are time synchronized with GPS receivers on each unit. The calculations that we're doing are all time synchronized to an accuracy of better than 1 microsecond. So when we measure the frequency at Philadelphia and Baltimore and we perform a subtraction, the time error is less than 1 microsecond. We also can use the ad hoc trending function of the RT gauges, and this is done by clicking on the down arrow, then the ad hoc chart, and this will bring up a chart of the last 2 hours of frequency data from Baltimore. It was shown on this chart. You can see that the signal has roughly been around 60 for the past 2 hours. We can zoom backwards in time by pressing this arrow. This will take us back 2 hours in time, and we can go back to the basically the infinite past, and in fact we can go back several years if necessary to examine the behavior of the grid under different conditions. So a single click will allow us to go back 2 hours. We can enter the time range of interest in these boxes, and we can go back to the current time by clicking this box. Okay, well, so these are the RT gauges. These show the frequencies in the 3 areas, and each of these gauges have a trend behind them. We'll next go to the image charts. These show the characteristic of the system in terms of its harmonic content. The upper left chart shows a surface chart of frequency over time. This x-axis represents the frequency of the oscillation in measured in hertz, and we are going from very slow frequencies of 0.01 hertz up to a total of 10 hertz in the way we're doing the calculations. Time is shown going backwards along the y-axis, and the z-axis represents the spectral power in each of these harmonics. The chart right below it is the current spectrum, and you'll see now a peak building at about 0.35 hertz and also a peak building at 0.4 hertz. If these peaks continue to build over time, it will indicate that we have an instability in the area. So you can see these peaks are now sustained. Typically we don't see the peaks lasting that long. They may show up for a few seconds and then dissipate. The longer this peak stays, or if it grows in amplitude, this is an indication of instability. So we're seeing these spectral analysis done 20 times a second. It's updating approximately every 4 seconds on this screen. Now we also have a measure in the center of the screen of the overall quality of the spectrum, and that is indicated by essentially the area under this curve is shown by this area. So we're getting an indication that we're close to a warning zone at this time. You can also see that the peak is beginning to dissipate, thank goodness, and you can see the gauge is also coming down. So that means that we had a wave go through the system, and it's dissipating. The same information is shown on this Indian blanket chart. This shows basically frequency in this direction of the frequency of the harmonic oscillations. In the x-axis is time. This shows the past 3 minutes of the past 5 minutes of spectral content. The colors of red indicate peaks greater than 0.9, and when we have sustained peaks greater than 0.9, then we should be concerned, especially if we have a sustained peak for a period of 5 minutes or more. Now you'll see this peak reappearing. This is somewhat of an anomaly. We typically have not seen this in the last 3 or 4 weeks, so it's interesting we're able to record this. Now we'll look at this chart in a different view. We'll press the active chart view, and this will bring up the same surface chart, but this time I will have the ability to manipulate and view this chart at different angles. And I can do that by moving the slider bar around to get a different angle of the chart. You can see the peaks that we're concerned about right here. So these peaks are very anomalous in this particular region. We also can tilt the chart by moving the slider up to get a different perspective of the spectrum over time. These charts, these RT gauges, are showing the frequency, and you can see now the frequency in Baltimore is increasing above 60.02, which is above the NERC limit. The ACE value is relatively high. The phase angles, though, are fairly normal, so there's basically not a net inflow of power into the Baltimore area. The final chart we want to show is a phase angle difference chart. This will show us what we just discussed, is that there's basically very little power, net power flowing into and out of the region. The angle here, though, is fairly large between Philadelphia and Baltimore. That angle should not exceed 90 degrees, and so we can see we're in the danger area in terms of angles. The trends of these angles are shown on these charts. We also show the ability of the system to instantly communicate with key executives who may need to know the behavior of the grid, so through the RT messenger, these measurements these communication paths can be established immediately. Let's go back and take a look at the map to see if things are conditions have changed or improved since we last looked at it.